Hi class, for these problems we're going to be looking at the lowest common multiple. And here is one way to actually find the LCM for each of the values. So what I'm going to do is I'm just going to actually put the 2 here and then the 4 in this position. And then I'm just going to start looking for common factors, or in this case multiples. So I'm just going to say that this is 2 times 1 is equal to 2. Then 2 times 2 is equal to 4. And then 4 times 1 is equal to 4. 4 times 2 is equal to 8. Now, as you're finding these multiplications, these are your common multiples. And then eventually there's going to be more multiples. So for example, if you continue this pattern, so 2 times 3 is equal to 6, and 2 times 4 is equal to 8. Here is another multiple. Let me put these in green. And then the patterns actually continue on indefinitely. Now we want the lowest common of these multiples. So in this case, for this particular one, I'm just going to say that the LCM for the values of 2 and 4 is 4. Another way of viewing this is if you look at the prime factorization. So let me do this, and this may help you for larger numbers. So prime factorization. And I'm just going to say that 2 is technically 2, and 4 is equal to 2 times 2. Now your LCM, your LCM is composed of the maximum of the primes in each of the values. So you're looking at the maximum of the 2's, but you're comparing 2's here and 2's there. The maximum is 2 to the second. So in this case, 2 times 2, or 4. If you had any other multiple in the prime, if you had any other value in the prime factorization, you would include it. So in this case, this is another way of viewing it. This will help if the numbers are really large. So let's take a look at problem, in this case, problem 2 with the values of 3 and 15. And I'll do the same approach that I did earlier. So 3 and 5. And this is just so that you get the idea. So if you multiply 3 times 1, this is equal to 3. 3 times 2, this is equal to 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is equal to 15. And then 5 times 1 is equal to 5. 5 times 2 is equal to 10. And 5 times 3 is equal to 15. For some of these, you can actually see the numbers and already find the LCM. In this case, our LCM, it's going to be 15. That's the lowest one of these two. So let me just rewrite it as the LCM of 3 and 5 is 15. Let me just do the prime factorization on the side so that you see it. So technically 3, you're going to write it as 3, and then 5, you're going to write it as 5. So your LCM is equal to maximum of the 3 that appears on both. So in this case, it'll be a single 3. And then this is a multiplication. And then maximum of the actual 5's, well, only 5 to the first power. So it'll be 15. As I said, the prime factorization, it'll be easier if you were to have larger values. Let's take a look at problem 3. And then what I'm going to do here is, I mean, if you already see what the LCM is, it's fine. But let me just do a couple of multiplications so that you see the actual, the breakup of all the values. So in this case, 8 times 1 is equal to 8. 10 times 1 is equal to 10. 8 times 2 is equal to 16. 10 times 2 is equal to 20. 8 times 3 is equal to 24. 10 times 3 is equal to 30. 8 times 4 is equal to 32. 10 times 4 is equal to 40. And 8 times 5 is equal to the values of 40. We found it. At this point, this is your LCM. So you technically only need to find one of these. So LCM is equal to 40. But as you can see, if you continue this pattern, if the numbers are too large, well, in that situation, it may be a little bit of a mess. So let's take a look at the prime factorization, and I'll do it on the side. So for the values of 8, this is equal to 2 times 2 times 2. And the values of 10, this is equal to 2 times 5. So your LCM is composed, if it's large, if the number is large in this format, maximum of the 2's that appears on the numbers. In this case, it'll be 2 to the third. And then maximum of the 5's, there's your 5, or 8 times 5, or 40. It's just another way of viewing it. The numbers are not going to get really, really large, but if you see that this approach is taking a while, you can look at the prime factorization. And as long as you have a specific number in the prime factorization, you have to include it in the multiplication. So if there was a 3, you would have to include it. There's no 2 in here, sorry. I don't know how that got there. That's actually it for these problems.